How are you? Yes, you are searching for compiler. Yes, this is the video for you because from compiler easy scoring questions are coming, and after watching this video definitely you can confirm your marks. Because in this video I am going to cover the compiler in detail, what are the easy area. So different steps here: high level, pre-processing, assembly language, assembler, interpreter, relocatable machine, loader, linker, phases of compiler, lexical analysis, syntax analysis, semantic analysis, what is intermediate code, each and everything we are going to discuss here. Different phases we will discuss. After that we will discuss symbol table also. And how to utilize, means what is the implementation of symbol table, what is the complexity, how the complexity is coming. This will be going to discuss. Error handling, parsing, different types of parser, and what is the comparison between the parser. And after that there is optimization, peephole optimization, repetitively question coming from here, that is also we are going to discuss. Strength reduction of operator, and finally previous year's question and future year's question, that is the expected question. So why we are waiting, let's start the class. Okay, and if you are new to this channel, please subscribe to the channel, click the bell icon to get all the latest update and notification, and please click the like button. Please comment in the comment section after watching this video if you like this, then only. If you dislike, you can dislike also. So in compiler, when we are writing any program in compiler, right, we are not writing in program in compiler, we are writing any code in editor, that is C, C++, Java. After that it needs some compilation. So to compile that code, we are installing some compiler in our machine. That is the software. Compiler is the special types of software which converting our high level language, that is C, C++, Java, into low level language or machine language. There are two types of compiler. One is cross compiler, another is source to source compiler. Cross compiler means it is compiling in a machine A and producing the output or producing the code for the another machine B. That is called the cross compiler. Next one is source to source compiler. Source to source compiler means it translates the programming language into source code, like you are writing in one programming language and it is converting in another programming language. That's why it is called source to source compiler. Now here we are giving a source code. Now after giving the source code, here some preprocessor is required. So what is going on in preprocessor? The preprocessor task is that to remove the hash include, means the whatever including, removing all hash include from there and removing all the macro, like we are doing like hash define. This is the part of preprocessor. So all perform on file inclusion and augmentation macro in this area. After that it is coming to the compiler, right? So when it is coming to the compiler, now compiler will change it here to the assembly language. After the compiler, here we are getting the assembly language. So what is assembly language? Assembly language is not the binary or not the high level. It is a intermediate state. It is a intermediate state, that is the combination of machine instruction and some useful data needed for the execution. Now what the assembler is doing? Now after that it is coming to the assembler. What the assembler is doing? Assembler is doing that it is a platform of every hardware and operating system. Everywhere it is the assembler is important, but it is not a universal. It is depending machine to machine. But what is the output? It is the output assembler called a object file. Output of the assembler, it is combining everything and after that it is giving the output as a object file. You are getting an object file, right? So it is the object file provided by the assembler. It translates the assembly language to machine language. So here we got the assembly language and after that we got here machine language. Now after getting machine language, now linker, it is coming to the linker. What the linker is doing? Linker is linking. From with which linker will link? With the library files. So library files means here the linker part is what the linker is doing. Linker link and merge variety type of object file together because assembler is providing you object file. Now all types of object file it is merging together and it is providing a single file and make it as a executable file. That is the part of the linker. Now after that it is coming to the loader. So loader, what the loader will do? It will load that executable file and it will execute it. So loader loads this into the memory and execute it and calculate the size of the program because to execute how much size is required, that is also. So it will calculate the size of the program. And after that finally memory means where it is executed, that will be allocated. But in between there are something. What is the interpreter? So there is sometimes students are getting confused with the interpreter and the assembler. What is the difference between interpreter and compiler? So both are actually just like compiler, interpreter, but the difference is that compiler is giving you the total, means if it is totally work is going on, goes in one read. It will read one input and after that it will process the total. But interpreter is doing the same by the line by line. It is reading not totally. It is doing line by line, interpreter, and compiler scan the entire program and translate into a whole into machine code, whereas interpreter translate the program one statement at a time. That is the difference between interpreter and compiler. Remember that. And what is relocatable machine code? What is relocatable? You can relocate. When you can relocate it, it can be loaded any point of time. This code is generating so that you can load it and you can run it any point of time. That is called a relocatable code. So I hope these all are clear to you. Now I am going to the next step. So the next step is the phases of the compiler. So what are the phases of the compiler? Here first of all we are coming to the, here we are giving the high level language, right? After giving high level language, it is coming to the lexical analyzer. So lexical analyzer will do the stream of token. Here we will get stream of token. Or that is the some ID like identifier, operator, and it is sometimes called lexeme also. So from a program we will see all the identifier. What are the identifier here? What are the tokens here? What are the operator here? From this part question are coming. They are providing a program and from that program they are asking that how many tokens are there. So if you are interested, let me know in the comment section so that I will upload some video for identifying token. Next one, it is coming to the syntax analyzer. So syntax analyzer is working on parse tree. It is generating the parse tree. Parse tree because it is working on syntax, right? Next one is the semantic analysis. So semantic, after semantic analysis, the parse tree, it is semantically verified. So what is semantically verified? What is syntactically verified? For that, here actually before coming to here, I am telling one thing. You can divide this into two parts. We are dividing it into the two part, different phases. This is our first part and this is our second part. This part is common for all and this part is a machine independent. This part was machine independent. After that, actually after this one, not here, after this one, machine independent code. After that, this code generation and the machine dependent code optimization, these are the machine dependent. And till this, it was the common part. So phases of the compiler we are dividing into two parts. One is analysis phase and another is synthesis phase. Analysis phase is the common for each and every 1. That is a common thing for machine independent, but it is the machine dependent. So here lexical analysis divide into token and syntax analysis recognizing the sentences and the program of the syntax, and the language or the semantic means the meaning. What is the meaning? It will go for the meaning. Semantic analyzer check the static semantic of each construct means it is the meaning, and intermediate code generator generates the abstract. Each and every part I am coming in detail. After that, the synthesis analysis here, code optimizer and code generation. So code optimizer is the abstract code and final code is the code generator. So here now coming to the symbol table. So symbol table, why it is required? Because of these all the phases, here the symbol table will be required. Symbol table is a special type of data structure using by the compiler all the identifier name along with the type. Because we identify in the lexical analysis part, you identify the identifier. So there the identifier name and the type is written, and it helps the compiler to function smoothly, because if you don't know what is the type, what I have to do, then how it will work. So the lexical analyzer reads the source code from the, that is keyword, operator and separator, and this token, it will read the source character and produce the token. That was the part of lexical analysis. Now syntax analyzer is known as the parser. The parser, what we will learn, that is actually the syntax analyzer. Remember that parser is the syntax analyzer. And one main important is lexical analyzer is working on regular expression, and that's why here the machine required finite automata. Syntax analyzer parse tree is working on CFG, context free grammar, and here the machine is required, that is push down automata that we learn in TOC, and repetitively questions are coming from here, so remember that. So here it will generate the parse tree, construct the parse tree, and it takes all the token one by one using the context free grammar, right? Next one is semantic. Semantic is verified the parse tree. Now the parse tree is generated. Now verification is required. It will verify the parse tree, that is meaningful or not. Semantic means it is meaningful or not, right? Next one is the intermediate code generator. So intermediate means it is the common one. It's generate the intermediate code is a form which readily executed by machine. Any machine you can execute it. And finally, after that, machine dependent code optimization and target code generator, that is depending on the machine. It transforms the code and consume fewer resources, so specifically for that machine dependent whatever optimization is required, and finally it will generate the target code. So these are all the phases of compiler and why the symbol table is required. What is symbol table? I hope this is clear. Now next part is the implementation of symbol table. How to implement the symbol table? The symbol table is implementing using list or using linked list here, using hash table or the binary search. There are 4 types of representation. Now in these 4 types of representation, something you have to remember very carefully. It is using array method. First of all, this is using the array. So in array, if there are something you have to insert. So insertion is very fast, and in array whatever you have to insert, what is the complexity? Complexity is order of 1. And when it is about to search, you have to search something. Throughout that you have to search the token. Then what will be the complexity? Complexity will be order of n. From here question are coming. Okay. So here something you are trying to found, then it is we are not getting, that is use of undeclared name or something you are trying to insert. What is already there, you are trying to insert, that is giving multiple defined name. So this too is also important. Next part is the linked list. Now linked list means that you know it is the dynamically allocation is going on. So that is the linked list. So using linked list, whenever we are representing, then a pointer is needed, definitely pointed by the linked list, and the pointer name is first. Here the head pointer, that is name is first, through which the symbol table is pointing. Here also insertion will be order of 1, and searching the lookup, it is called the lookup. Lookup is order of n. But for the hash table, that is the concept of hashing. In the hashing concept, as you can directly search with the hash function, and that's why in the hash table the advantage is that the insertion of the lookup is very fast, that is order of 1, and searching will be also very fast. If insertion and lookup both are very fast, because according to the hashing concept. If you don't know the hashing concept and all, then you have to go for the data structure part, right? Now next one is the binary search tree. So when it is representing as a binary search tree, then the lookup is order of log n base 2. That is very important here. Remember that only in binary search tree, searching part is order of log n base 2. It is totally dependent on the data structure, but for getting marks, remember it. Okay. Mainly the hashing, the lookup is order of 1. That was the advantage. And here the insertion and lookup is order of log n. That is the logarithmic. Sometimes questions are coming like this. Now next one is the error handling. Error handling, two types. One is runtime error, another is compile time error. That you all know. Now what is runtime? What is compile time? Compile time error when it is compiling before execution. Which type of error are this? So here lexical, syntactical, semantical and logical. What are the lexical? Lexical means that is misspelling of identifier, keyword or operator. Spelling mistake is the part of lexical. Syntactical means some semicolon missing, or you have started bracket but the bracket is not, end bracket is not there. Unbalanced parenthesis like the bracket means you have given second bracket, end is not there. First bracket, end is not there. Semicolon is missing. These are the syntactical error. Semantic means it is always working on meaning, right? So incompatible value assigned or type mismatch between the operator and the operand, that is the semantical part. And logical means that is the code not reachable or the infinite loop. This is the logical error. So these are the compile error. Now what is runtime error? Runtime error is that when it is takes place during the execution, at the time of execution. Which type? If user is giving a invalid input, then it can be, or maybe the parameter, because of some system parameter, adverse system parameter, this can be happen. So this is the runtime error. Now coming to the parsing. Parser is the part of the syntax analysis, right? Here we saw that here we are generating the parse tree. Here it will generate the parse tree and it is working on the CFG, context free grammar, right? Remember this part, it is working on CFG. There are two types of parse tree. One is bottom up parse tree, another is top down parse tree. What is the difference between bottom up and top down? We are writing the grammar, right? Key S implies A, S, B or epsilon, and after that maybe here I am writing capital B. So this capital B is something in that way. So when you are starting with S and you are trying to see the string is generating or not, that is called top down. When you are starting from bottom, that with the string you are matching with the grammar which which production is matching, and ultimately you are able to reach to S or not. That is called the bottom up. That is the main difference between top down and bottom up. So here top down parser is that ki recursive descent parser and LL1 parser. So here very important something is required. The LL1 parser is called also the predictive parser. This is also called predictive parser. And bottom up is divided into LR parser. There are LR0, SLR0, LR1 and CLR1. And here another one is operator precedence parser. Now remember one thing, that this LL and LR, what is the difference? This first part is telling you how the scanning is going on. Okay. And second part is telling you the derivation tree. Always the second part is telling you derivation. First part is telling you scan and second part is telling you derivation. So what is the meaning of LL? LL means left to right. The scanning will be for the LL. The scanning will be left to right. Okay. Left to right scanning. And this L meaning is that is leftmost derivation. This is leftmost derivation. And what is the meaning of LR? LR is also, that is also left to right scanning. This is also left to right. But this R is rightmost derivation. This is rightmost derivation and in reverse order. From here, lots of questions are coming. Remember that. LR is rightmost derivation and in reverse order, and scanning is left to right. Somewhere students are getting confused. L means they are thinking some different. It is L is left to right. Both are left to right scanning. Here scanning part is both. For both it is left to right, and for R only it is rightmost, and for here it is leftmost. I hope this is clear, right? And now what is the SLR? SLR means the term for SLR, that is actually simple LR. This is called simple LR. And CLR means that is canonical. This is part is canonical LR. Okay. So here the parser comparison. This is very important. Question are coming from here. CLR is the higher one. After that LALR. After that SLR, then LR0. Or if you are comparing like that, then it will be CLR is highest, after that LALR, and after that LL1. Okay. So remember this, always question are coming from here. And according to number of state, if you are trying to convert a same language in different parser, according to the number of steps, like if LR0 is taking N1 steps, SLR is taking N2 step, and LALR is taking N3 step, and CLR is taking N4 step. So this all will be same number of state. LR0, SLR and LALR all are taking same number of state. Only the CLR is taking more state or same. It can be greater or equals to. That's why you can see it can be greater or equals to, and these all are same. From here question are coming. Remember that. Next one. So here I already told this, that topmost parsing, bottommost. Here top down is leftmost derivation and bottom up is the right reverse order and the rightmost derivation. Reverse rightmost derivation. Okay, so top down parser construct the grammar free from ambiguity. Remember this also. Always the topmost grammar cannot work in ambiguous grammar. It have to be free from ambiguity. And top down parser is the leftmost derivation always construct, and it's allow the grammar free from left factoring also. Free from left factoring also. MCQ question are coming from here. Next one is the LL1. LL1, that was the left to right and the rightmost derivation, leftmost derivation also. This is the LL. Why the name is LL? That is look ahead. This L is telling look ahead. LL1 parsing construct the grammar which is free from left recursion, common prefix and ambiguity. Okay, and it is non-recursive. This parser is also non-recursive. And this one, what is the meaning of this one? This one is telling you one is look ahead symbol. It depends on one look ahead symbol. That's why here it is one. That is the meaning of one. Okay. Next one is the top-down parser. So for the top-down parser, there is two types. One is recursive descent and another is backtracking. Recursive descent means the common top-down parsing. It's called the recursive because, why? Because it is suffering from backtracking. It is descent. And here backtracking means, what is the backtracking? Backtracking means when one derivation tree, if you are using one derivation tree and production is failed, then another, you can go for the another production. For the another, for that same rule, you can go for the other same production. Another rule of the same production. That is called the backtracking. Now, in bottom-up parser, there are LR. Under LR, there is LR0, SLR0, LLR and CLR. Right? Now, here operator precedence parser. What is going on here? Operator precedence is generate the parse tree from given grammar and string. But only condition is two consecutive non-terminal and epsilon never appear on the right hand side production. Here it is the operator precedence. Two non-terminal, two consecutive non-terminal cannot be here in the right hand side. Okay, and the epsilon also cannot be in right hand side. That is the main condition for the operator precedence. Next one is peephole optimization. This is very important. Question are coming and this is the last topic of this video. I hope you are watching till now. So peephole optimization is the type of code optimization where small part of the code, it is peephole, small part of the code perform and very small set of instruction and segment. The small instruction code is called here where we are using, this is called peephole. Why it is required? Peephole is a machine dependent optimization. Here question are coming. It is a machine dependent optimization. And objective is for that improve the performance, reducing the memory according to memory and reduce the code size also. These are the main focus of peephole optimization. Now how it will do? This is doing in that way. Here actually question are coming. They are giving some example. After that they are asking that which type of optimization. So redundant load or store elimination. Here unnecessarily some redundant you are doing. Y equals to x plus 5, I equals to y and z equals to I. So here this part I can reduce to I equals to y. After that I can write w equals to y star 3. This is called redundant load and store elimination. Some unnecessary variables, some unnecessary steps you are doing that we can remove. That is this type are called the store load or store elimination. They are giving this type of example and after that they are asking which type of optimization it is. Next optimization is constant folding. Constant folding means the multiplication was there, x equals to 2 cross 3. Now directly you multiply it and you put the value. This is the optimized code. So this multiplication was a overhead for the compiler, that is you have done and you wrote that is a constant folding. Next one is strength reduction. Strength reduction means actually multiplication is a very highly costly operation. So from this highly costly operation, if you are converting it into left shift operator or right shift operator, like if it is divided. Dividation means when the concept of left shift and right shift is that if something is multiplied by 2, okay, so here it was like that y equals to x plus x. X plus x means that is 2x. So that we can write like x left shift by 1, because how it is possible? Left shift is always doing multiplication of 2. Why? Because if I am writing 2, it is 8. It is the code 8. Now I am doing left shift here. If I am doing left shift, here it will be 1. This is 0, 0, 0, 0. Now this will be your 16. That's why it is multiplied. It was 8 and after left shifting it is multiplied. And same way, if you are right shifting, this is 0. This 0 will be discarded. After that 0, 0 and here the 0. And here 1 will come. So this was 16, now it is 8. So when it is right shift, then it is divide by 2. That's why we can change the multiplication to the left shift and division to the right shift. This is called the strength reduction of the operator. It is a less consuming and less costly operator. Consuming less, and here it was consume was higher. So that's why it is called the strength reduction. So here are some more example of strength reduction, like x by 8. This one, when we are doing 64, then it is, so it is the concept coming from here. 2 to the power 6 means left shift 6 bit. That is multiplied, so 1 bit. That was multiplied with 15. That's why 2 to the power 4 is 16 minus 1. That's why left shift 4 minus 6. And here it is another example. So these are the example of reduction, strength reduction of operator. Finally, the code optimization. This code optimization is a machine independent. Till now, Peephole was machine dependent. It is a machine independent optimization where we are using loop optimization like code motion, loop unrolling and loop jamming. Code motion means reduce the evaluation frequency of the expression. Loop unrolling means execute the less number of iteration. Jamming, here question are coming. What is loop jamming? Loop jamming means combining the body of the two loop whenever they are sharing same index. Then it is called loop jamming. And here is also constant folding, that is replacing the constant during compilation, and constant propagation, that is replacing the value of an expression during the compile time, and strength reduction, that replacing the costly operator by a simple operator. So these are the part of the code optimization, that is the independent, machine independent. So finally, for previous year's question and future year question, you have to come to Unacademy platform, that is also free classes. Today only when I am recording this video, that is 2nd February. So in this 2nd February 2022, I am recording this video. Today 7 p.m. the class is there. For this topic, we will practice all the previous year's question and future year expected question. If you are interested, join this session using my referral code Priyanka, PRIYANKACLIVE. This is totally free of cost. My category is UGC NET or SET. This is my category. Just you have to install Unacademy app, and after that you can join the session. I am giving the link in the description below, or if you are watching later, then you can watch the recording also of that class, and you can download the PDF. You can practice the question also. In that way only we will do it. All the topic, for the topic video I will upload in this channel, and we will practice the question on Unacademy, because there it is more easy to practice MCQ through the leaderboard, through the poll, timing control and all. So stay tuned with this channel and try to follow me on Unacademy also. Thank you. Bye bye. See you soon in next video, and let me know in the comment section how it is and what is the next video you expect from me, so that I can prepare the next video, next topic for you. Bye bye. Have a good day.